You may have heard that we are all made of star stuff. And this is true for our very own star, the Sun. A second-generation sun was forged from recycled materials in a giant molecular cloud, a stellar nursery. Hi, my name is Michelle Cullen, and I teach astronomy at Prince William Sound College, located in beautiful Valdez, Alaska. Journey with me into the heart of a stellar nursery where we can learn about star formation basics. Here's an image of a giant molecular cloud, the Orion Nebula, where stars and solar systems are being created right now. What is a recipe for a star? Well, use an infrared telescope to locate a dense region of space and add some materials. Let's start out with 70% hydrogen, 28% helium gas, and 2% of stardust. That would be heavier elements that are very small. Carbon, sulfur, nitrogen, everything up the periodic table. Allow the mixture to freeze into a star-forming fog. To initiate star formation, stir gently with a cosmic nudge. This could be from a supernova or the shock wave from an igniting nearby hot star. Allow the shock wave to press the hydrogen and helium together so they can begin to swirl and form the core of a baby star. The core will have enough mass that its gravity will begin to attract nearby hydrogen and helium gases to feed the ever-growing protostar. It will continue to gently spin, and molecules will begin to get crowded and forming an outward thermal pressure. This outward pressure will balance with the inward attraction from gravity. Allow the mixture to continue to contract and expand with these two pressures from thousands to millions or even a billion years. As a protostar grows, it might even spin quicker and shoot out some gas of jets from its north and its south pole. These can be seen in these beautiful images. As a protostar gathers more mass from the molecular cloud around it, it gets denser and denser and eventually will collapse inward and spin even faster, just like an ice skater pulling in her arms as she spins very quickly to conserve angular momentum. We're now ready to observe what is known as the pizza dough effect of the formation of a star. Just like a pizza dough being thrown into the air as it's spinning, the spinning cloud will flatten out and will become a planetary disk. And it's the solar nebular theory of how planets are formed, because within the spinning pizza dough disk, the little clumps of material will gather their own mass of elements around them and form planets. The protostar keeps feeding until the nearby molecular cloud is used up, or until it reaches the critical ignition temperature, 100 million Kelvin, and then you'll have thermonuclear fusion. Hydrogen will start being converted into helium, and your star will light up. When your star is shining, material in the neighborhood will be cleared out by its solar wind. All the dust and fog will be gone, and the starlight can shine out into the rest of the galaxy. The radiation from the igniting star can also send some propagating shock waves around into any nearby molecular clouds and nudge the formation of, you guessed it, new baby protostars. How fast a star will form and the type of star that will end up depends a lot on the initial density of the molecular cloud. A super dense region can quickly snowball into a massive giant star in as little as 10 to 100,000 years. These type O and B stars are formed quickly and live short, luminous lives as they run through their massive fuel sources. But an average molecular cloud, probably like one that we were formed in, might have an average density and gather up the amount of mass that our sun had, and it takes about 30 million years for our sun to form. But if the star comes from an impoverished, thin cloud, it could take a lot longer, maybe even 100 million years to form a small red dwarf. To put this in perspective, the main sequence life of a big 15 solar mass star is very short. Like I said, millions of years to form and millions of years to die. But our sun will form and live for billions of years. So if a person lived 80 years as our sun, as an analogy, a 15 solar mass star would live 1 month. I hope you have a better understanding of how stars and planets form in the heart of a molecular cloud.